In this video, we're going to look at some quick worked examples of factoring basic algebraic expressions. Let's start off with an example of an algebraic expression. 2x plus 10 is an example. What we're going to do is look at factoring 2x plus 10. When we factor an algebraic expression, we put it into a set of brackets. Factoring is the opposite to expanding. What I'm going to do is now look at the highest common factor of the numbers and the highest common factor of the x's. So we say to ourselves, what's the largest number that goes into 2 and 10? That's the highest common factor. The answer is 2. So we have a 2 outside the bracket. We can see that we only have an x in this particular term. Therefore, it's not common to both, and we don't need that outside the bracket. We now open the bracket up, and we say to ourselves, what do we need to multiply 2 by to get 2x? The answer is x. What do I need to multiply 2 by to get plus 10? The answer is plus 5. Alternatively, you could say to yourself, what is 2x divided by 2? The answer is x. What's plus 10 divided by 2? The answer is plus 5. So this now is factored. If we were asked to expand this, we would simply multiply it out. And we've seen that before. So if we were asked to multiply out 2x plus 5, or expand the bracket, we would do 2 times by x, which would give me 2x, and then 2 times by plus 5, which is going to give me plus 10. So we can see that we've got back to our original. So this is factoring, this is expanding. Let's look at factoring 5p minus 15. So what we want to do is put this back into brackets. We've got 5 and 15. The highest common factor of 5 and 15 is going to be 5. We can see that we've only got a p in this particular term, so p is not common. I open up the brackets. What do I need to multiply 5 by to get 5p? The answer is p. What do I need to multiply 5 by to get minus 15? The answer is minus 3. And we need to be careful with this sign. Here we've got a plus, here we've got a minus. That now is factored. So all I've done is taken the highest common factor of numbers, the highest common factor of letters, taken that outside the bracket, set the bracket up, and then we have now in the bracket what we need to multiply 5 by to get the original expression. Let's look at another one. Let's say we've got 6x plus 15. So we want the highest common factor of 6 and 15. What's the largest number that go into both of these? The answer is going to be 3. We can see that x is not common to both, so we don't need that outside the bracket. What do I need to multiply 3 by to get 6x? The answer is 2x. What do I need to multiply 3 by to get plus 15? The answer is plus 5. Or, if you like, what is 6x divided by 3? The answer is 2x. What's 15 divided by 3? The answer is 5. So now we've factored the expression. Let's look at another one. Let's say we have now 4x squared plus 6x. This time we have an x in both terms. This is x squared. If you like, you could write this as 4 multiplied by x multiplied by x. Here is just 6 times x. The largest number that go into 4 and 6 is going to be 2. We have now x squared and x. So the highest common factor of x squared and x is just x. That goes on the outside. I say to myself, what do I need to multiply 2x by to get 4x squared? The answer is 2x. What do I need to multiply 2x by to get plus 6x? The answer is plus 3. So that now is factored. If you want to check that this works, expand it back out as we did here, and we will see that we'll end up with this expression. Let's do another one. Let's say now that we'll take 7 and we'll have p to the power of 3, and then we'll have minus 21p squared. So this is a slightly harder example. Here we've got now 7 and 21. The highest common factor of 7 and 21 is 7. That's the largest number that go into both. What we have here is p cubed. P cubed is p times p times p. And here we have p squared. P times p is p squared. The highest common factor is p squared. We can see we've got p squared and p squared. That will go outside the bracket. Then I say to myself, what do I need to multiply 7p squared to get 7p cubed? The answer is p. Then I say to myself, what do I need to multiply 7p squared by to get minus 21p squared? The answer is minus 3. Or, if you like, you can say to yourself, what is 7p cubed divided by 7p squared? The answer is p. What's minus 21p squared divided by 7p squared? The answer is minus 3. So depending on how you look at it, you might want to work forwards or might want to work backwards. Let's do one more. Let's say we've got now 10x squared plus 15x. The largest number that go into both 10 and 15 is going to be 5, so that's the highest common factor of the numbers. We've got x squared and x. The highest common factor is x. We open up the brackets. What do I need to multiply 5x by to get 10x squared? The answer is 2x. What do I need to multiply 5x by to get plus 15x? The answer is plus 3. So we've now factored that algebraic expression. As stated, if you want to check that you have this right, you can go ahead and expand. Expanding is the opposite to factoring. So we'd multiply 5x by 2x, which would give us now the 10x squared. And then we'd multiply 5x by positive 3, and that would give us the plus 15x. So we can see if we expanded it out, we would get back the original expression. So this is factored, this now is expanded.